Good morning. Can you hear us okay? Good morning. If you can hear us, wave.
Wave.
Welcome this morning. We are the Mad Scientists. Good morning. Good morning. Look, they all have goggles on. All right. They're ready.
Shaky first.
Okay, we're going to get started this morning. Our first experiment is going to be glowing oil and water experiment. There's some very important things about oil and water that you probably already know. First of all, does oil and water mix?
No.
No, that's right. Teachers, you might have to repeat their answer because we can't hear them very well. So, no, oil and water do not mix. Actually, this explains why oil spills on the ocean float on top of the surface. Hopefully, nobody's ever had a grease fire in your kitchen because you are not supposed to throw water on a grease fire. It makes a big, big mess, and it makes it a lot worse. So please don't throw water on a grease fire. Use salt. It works best in case you're in that situation. Hopefully not. So now that you know that they don't mix, let's talk about why. Well, it's called density. Oil always floats on top because it's less dense than water and won't mix because water molecules are on the move. Right? On the move? On the move.
That's right.
Okay.
They're attracted to each other.
Yes, they're attracted to each other and the oil more than the oil molecules. Sorry. The molecules of water can't mix with the molecules of oil. Even though you try to mix them up and you shake them up, nothing's going to happen. So let's check out a little video here about density.
Density. Why does oil float on water? Don't know the answer? No worries. We shall find the solution.
This is again because of density. The balloons
Stop it. Okay.
So what do y'all think about density?
What happens with density? Makes things.
It's right. It depends on if it's going to float or sink. So right now we're going to get started on our oil and water experiment. My name is April, and this is going to be my helper today. Her name is Tegan. So we have our ingredients right here. We have baby oil. You're going to need a clear container, the pipettes. You have some spoons to stir, neon paint. We didn't have any small bowls, so we're using clear cups. So first, what you're going to do is you'll begin by filling up your dishes with water. We just used a little bit of water in the bottom of our cup. And then we're going to add our paint. We're using neon orange, green, purple, and pink. And we're going to add about a teaspoon of this in there in each one. So I'm going to hold it up so we can see. And put it in there. Okay. And now we're going to use our spoons to mix it up. This is a pretty easy project that you can do at home with your parents or your teacher. Since this is paint, we recommend not wearing new clothes. Please wear clothes that you don't mind getting dirty, or wear a smock like we're wearing today, just so that you don't get all dirty, because it will stain. Just make sure you have adult supervision when doing any project at home, and always ask permission. Do you ask? Yes. Yes. It was just pointed out to me that I do not have my safety glasses on, so.
But you have glasses on.
But I do have glasses on, so it is going to protect my eyes. So I guess I'm going to put my, oh, they're all foggy.
Yeah.
I don't know if I can see.
That's not very safe.
They're all foggy, so we're going to leave there. But I do have my glasses on, so we can leave those on. Okay. So here are our four colors. I'm sorry, I can't count this morning. 4 colors. So now here's our clear glass container is what we're using. So I'm going to ask Tegan here to help me pour this whole bottle of baby oil into there. It's a lot of baby oil. And maybe some in this other one, just so you can see it really good. Okay, pour it in there. It's about right here. That should work. That'll be good. Okay, we're going to set these aside because we have another project coming here in a few minutes. So what we're going to do now, I'm going to take the orange or the green, and Tegan has the pink and the purple because those are her favorite colors. Right here, I have 2 black lights. In a few minutes, we're going to turn on the black light so you can see these. This in the middle here. Can y'all see the glass bottle?
Yes.
Okay. All right. So we're going to turn on the light. They do get kind of warm, so once again, do this with your parent or an adult supervisor so you don't burn yourself. So, oh, thank you. Thank you. So this is really easy project. All you have to do is suck up a little bit of the paint in your pipette. If you want to get the lights, Miss Lisa. Let's see if this will work. And we're going to add, I know it's dark. Can you see the light? Okay.
Yeah.
Add a little bit of the different colors in here. I'm not sure if y'all can see that part.
What I would do is move the
Should we move
container forward
move it
and then
forward?
push the lights together
Okay.
and see if that works.
You hear that? So each of you fill it up only to the number 5. Take turns, go around.
I'm not sure. Can y'all see that part?
Turn the lights back on.
Turn the lights back on.
Wait.
And add some more. Add some more.
Add some on. Okay. We're trying to do it where you can see. Maybe I can turn off the light. These lights a little bit. Maybe Miss Lisa can help us move it a little closer here.
Or maybe I'll move that closer to that.
Let me add some more orange. Since Miss Tegan likes to use a lot of,
Oh, yeah.
Some of the
can you
orange.
see that in there?
Peach.
Hold it up. Miss Lisa's gonna come there for you. Check it out.
Oh.
And they all stayed at the bottom. See that? It almost looks like, what are those things called that you put in the water and it makes beads? Orbeez.
Orbeez.
Yes, Orbeez. It looks like Orbeez at the bottom. And if you use maybe some glow-in-the-dark neon paint, I'm sure you can probably see it a little better. Our black lights are a little dim this morning. So really sorry about not being able to see that glow-in-the-dark. So, is what happened what you thought would happen? Did you think that they would all mix together? Or did you think they were going to float?
Did you guys think they were going to sink or float? She's asking.
Sink.
You thought they were going to sink. And look, they're all at the bottom right now. All at the bottom. They're kind of dissolving together.
All right, so here's the next thing. That's kind of cool.
I know. Does anybody have any questions?
Do you guys have questions?
No.
No? Okay.
You had to hold up your
Well, Tegan and I are going to move over just a little bit.
Well, we're
so-
gonna need Tegan's help too, though. She's like, our work's not done.
Uh-oh. So we're going to pour all these
We got
in
more
together.
stuff. We're making a mess. We're ready to make some more messes.
Heck yeah. So I'm going to move over just a little bit.
Okay, now.
Take this out of the way. Pardon me. Cleaning crew.
Ready to make a new mess?
Yes, we are.
Okay, Miss Tegan, would you like to be on this side? Well, here, let me stay on this side because I'm just over here in a second. So this is the warm water. I need you to pour this in a second.
Okay, so
Okay. First of all, as my colleague April was saying, my mad scientist, my name is Igor, by the way. I don't know why it says Kyle on it. Of course, we have adult supervision is needed because of dry ice temperature is extremely cold. And it's like, you can see me? Hold on, let me get some of this stuff.
Oh, you can't
I'll
see.
show you what it looks like. You notice I have gloves on. It's because it's extremely cold. It can get down to -109 Fahrenheit. You know, the coldest it gets in South Texas is about 40 degrees. And I know that we all think that's cold.
Yeah.
But this gets minus 109
That is a
degrees.
lot colder.
That's a lot colder. It's like they're going to close the school if it's minus 109. Okay. And so,
So we have a little video.
we have a little video about why dry ice is so dangerous.
Give us a second. There you go. Doesn't want to move.
It doesn't want to move. Hold on.
I'm sorry you can freeze and die within seconds. That's giving us severe frostbite. In addition to that, storm clouds and unfelt containers can be dangerous. This is why ice supplements. That is, it directly gets converted from solid state to gas easily. Hence, in airtight containers, it has produced severe effects.
So you see, it is very dangerous, and that's why we need adult supervision. It's that those little devils are, they can be troublesome.
Yes.
So we don't want to mess with
Yes.
those. Okay, so the first thing that we're going to have to do is talk about our materials. And we have our small bowl, and it's a cup of warm water. We have a whole pitcher here. And we have some cloths here. I don't know if you can see them. I don't want to spill it, but it's Dawn dish soap and some towels that I cut off into like some cloth that I cut out of a towel. Okay. And of course the dry ice. You notice I do have my gloves on. My assistant has her goggles on, and so we're ready to go. So you can pour a little warm water in there for me, please. Man, I think that's, well, let's do a little bit more. Let's see how it goes. Okay, that's good. Thank you, ma'am. All right, so I have my gloves on, and you see how it kind of looks like a snowball, and you see it's already sublimating, and that's just a fancy word for me. It's changing. Okay, so there we go. You see a lot of these, you're probably at your Halloween parties, and you might see when you go trick-or-treating, you might see this be a fun thing to do. Let's see, I'm going to do one more and two in there. Ooh, it looks like a cauldron. So this would be kind of a neat thing if y'all want to do this for Halloween, but of course with adult supervision. All right, so I'm going to set this aside. We have to set this aside because if we leave it on the table, it's going to freeze. So I'm setting this over here away. That. Okay. And next is our procedure. And see, so we've got our dish soap, looks like what we're talking about. Got this. And now what we're going to do is take one of these cloths and we're going to put soap around the edge. Does that look cool when I do that? Cool.
Awesome.
And then we're going to take a cloth and we're going to drag it across. And does anybody have any idea what's going to happen when we do that?
Spray.
Maybe it's going to make a bubble.
It might make a bubble, but we don't know either. So that's why we're here for, right? So let's figure it out. So I'm going to grab one of these cloths. I still have my gloves on just because, I don't want to touch the dry ice. And what we're going to do, see, I'm making a mess, so we'll clean up. I'm going to go around the edges with the soapy water on the towel. Get that nice and soapy. Okay. I'm going to get a little bit more soap. And then it turns into a cloth. And we're going to drag it across here. Let's see how this works. We haven't done this yet, so.
Oh, I see, to make a big bubble.
Ooh, double tap.
Yeah, and you guys tap it on the way to the edge.
So get it on the edge. You can see a little, oh, it popped.
He's popping.
Yeah, let's try a different one over here. This one's a little bit bigger. I'm gonna put some more soap around the edge. We're gonna make a big mess.
Well, just like any experiment, do they all work? No. No, not all of them work.
Here we go. Is it making a bubble yet?
And you guys started the edge.
Let's see. Okay, we're covering it up.
Oh, maybe we need more dish soap.
Maybe some more dish soap in there. Some dish soap inside.
Oh, just it's
Oh, on your rag.
On the rag itself.
Yeah, there you go. And then maybe rub it together.
Yeah.
And sometimes there might be instructions for your science project, but you have to improvise just a little bit. You
We
never
all
know.
know that these things work on YouTube.
I know.
They work on
They
YouTube.
work on YouTube.
But they don't work in Transylvania here sometimes. Okay, now we're gonna try.
There you go. Oh, that's great. And I said, you might have to do it a couple times.
yeah, you might.
Let's see the bubble.
There we go. Keep going.
Slow.
He's going slow. I see a bubble. Everybody fingers crossed. Very good. Easy. Easy all the way through. Oh, I think we got it. Let's watch.
Uh-oh. Now what's gonna happen? We've never made it this far before. We don't know what's gonna happen.
What do you think's going to happen?
Explode.
Yeah. It's
So it's a
bubbling.
good thing we have our goggles on, right?
Yes.
Okay, we're good.
It's
Look,
We don't know how big this thing's gonna get.
look.
Oh no.
It's growing a little bit more. Oh, now we're at the top of the bowl. Let's see. So is this building up pressure?
Yes.
Yes. Oh, look.
Oh, it's shaking.
Oh my goodness.
Dry ice it does not go to liquid right away. I know a lot of you think it goes from a solid to liquid to gas, what you learned in science. But the thing about dry ice, it goes from a solid directly to a gas. And that's what we're seeing right there.
Look how big it's gotten.
Did you hear that? Dry ice goes directly from
Oh.
You hear it bubbling, you hear it bubbling?
it's the liquid.
So how long do you think it's going to take before it pops?
An hour.
Hours?
An hour.
I don't know if we have an hour.
Do we have an hour?
Hopefully we have seconds. Oh, look. Look.
There, it's starting to shimmy a little bit. Got a bit of the rainbow. We can see a little bit of the colors. This would probably look cool. Like if you do this with an adult, you can also drop a glow stick in there, and that's always fun too. Some cool colors.
Nope, it's still going.
What's gonna happen when it pops, though? That's the question.
I know.
We've never seen that before. Maybe on YouTube.
Oh, look, it's starting to shake.
Uh-oh.
Wow, look how it's shaking. Why is it shaking?
Wow.
Whoa! Whoa!
Look, how
Pretty
awesome.
cool. Pretty cool. And so you can kind of play around with it too. It's like it's not
Just
too
don't
cold.
touch the water.
Don't touch the water. And again, I have my gloves on. So kind of like what we were talking about is like ice turns into carbon dioxide. That's a solid carbon dioxide is dry ice. And that warmed inside the bowl, but then it changed to a gas because we had a little bit of water. And it looks like smoke, but it's actually a gas. That's the dry ice. That's carbon dioxide. And again, another safety tip, you have to make sure you work in a well-ventilated area because you don't want to breathe this stuff. It's no good. It's just like from a car. It's no good. All right. And the pressure inside the bowl that's what happened, was increasing. And that's why it didn't have anywhere to go, because we had that soapy film over it. And so that's what created that. And it's like the quantity of gas increased with the limited room because of the water, and that's what caused it to expand. So it's a pretty cool little experiment. It'll be fun with adults, of course, as we always say. Yeah, do you have any questions for us?
Oh, we have questions.
It looks like Miss LeBeau's class has, might have a question. We can't hear you, Miss LeBeau.
If they don't have, they can type it in the chat.
Maybe you can type it inside the chat. There is a chat feature either at the top of your screen or at the bottom of your screen. It's just a little chat bubble. If you'll type it in there, we can't hear you, and we'll get to your question as soon as we can. Okay, well, we're going to move on.
Okay, we got another mess to clean up. Imagine that. Now we're going to see what happens with this next one. We might get a good mess if we're lucky.
Ooh, let's hope so.
Move this aside. Take some for you too. Thank you, ma'am. The table's nice and
I
clean
got a
now.
spick and span
We got
area.
Dry ice. Move
Okay.
this aside. We'll leave our little cauldron. Oh, still doing our bubbles over here.
Next we have Miss
Okay.
Lisa.
Hi, everybody. We are going to do an oozing pumpkin experiment today, which hopefully will be awesome. This is a kid-safe version of the popular exploding toothpaste demonstration using materials that are easier to find. The initial experiments that I was looking at were having lists of ingredients that you couldn't just go and find. So we have this one. Back up, please.
I'm sorry.
Thank you. Any kid with a great adult helper can perform this activity safely, and the results, hopefully, will be awesome. Okay. What you'll need is a measuring cup, 4 ounces of 40 volume hydrogen peroxide, which is not the peroxide you find at HEB or Walmart or CVS in the brown bottle. You will need a super cool adult to go to a beauty supply store to get that for you. Dishwashing,
super cool
a
adult.
super cool adult. Well, this is a super cool experiment, so you need a super cool adult to do it with. You need dishwashing liquid, food coloring. You need some kind of a container to put it in. 1 liter bottles work well. 1 liter soda bottles work well. We're going to use a beaker for one and a cup for another one because we have to fit the cup in a smaller space. So we needed a smaller container. And you need dry yeast and warm water. So what is the first thing that we always do?
Put on our goggles.
Put on our goggles.
Right.
That's right.
Tegan's already
Which
ready.
class was that?
Gonzalez.
Miss Gonzalez. Way to go. Fantastic.
Hey, safety's fun.
Okay, so, and we also need to put on our rubber gloves. Tegan's already got hers on. Okay, so we already prepared our room. If you are going to do this experiment, you either need to do it outside or you can't see from where you're at, but we have a tarp covering the floor in front of this table. You can hear it. This has the possibility of making a huge mess. So don't do it in a small area that's going to be hard to clean. Don't do it over carpet or anything like that.
So hopefully we'll have a cool mess.
I hope so. Okay, so we're going to use our measuring cup here. Man, these are hard to use our measuring cup. We're going to get 4 ounces of the hydrogen peroxide. That right there. Can you pour it to there? Yes.
I think it's
to this line right here. Perfect. Thank you, Mia. Our spoon will not reach. Oh, it'll reach with your little hands. You can stir it. Okay, so we put our 4 ounces of hydrogen peroxide in here. To that, we're going to add a squirt of dish soap. We're not squirting the dish soap. We're just kind of
Little bit of dish.
little bit
They're gonna be reacting.
out of our clear plastic cups.
Not yet, there was no reaction.
Next, we have some food coloring. Would you like to put in some food coloring, Miss Tegan? We're using red today. Since it's Halloween, it'll be fun in the next part of the experience. Okay, so I need you to gently stir it. We don't want to slosh it around. Just gently stir it till it mixes together. Perfect. All right, that looks good. Next, we have the yeast. We're going to put in a small bowl, and we need 4 tablespoons. I put the teaspoon, 1 moment. 4 tablespoons of very warm water.
I have this stuff, but I haven't decided if we're gonna do it. I wanna see.
1.
So she's adding warm water to
2.
and yeast looks like a powder,
3. Thank you.
and you add it to.
And 4. So now, my assistant's going to stir this up. If the mixture turns out too thick with the 4 tablespoons of water, you can always add a little bit more water to till it's a thin consistency, and you can pour it. Okay, so Tegan, are you ready for the fun part? Oh, there's just a little bit of bumps.
Nice, you said it was gonna be messy.
It's gonna yeah.
Whiskey.
How's it doing? That's pretty good. There's some stuck on the end of the spoon, but I think that's okay. All right, so you wanna pour it in there? So you're gonna pour it in here, and then we're gonna see what happens.
So that's it.
What's happening?
Slowly.
It may take a little bit.
Do you see any changes, guys? Maybe a foam? Is that a foam?
It's kind of foamy. It's kind of
Looks
foamy,
like it's going up.
but
It was,
it's turning out to see. Well, this is supposed to go.
Probably if I tried it, it would.
I'm getting some hints from the gallery
Add more
that say adding some more peroxide.
We're getting a little sciencey.
We're getting mad science.
They have their goggles on.
There we go. Looks like Big Red.
But do not drink it.
Then don't drink it.
This, by the way, this will irritate your skin, so make sure you wear the gloves with this for sure. Well, we have enough supplies to try this one more time. So, is the water still warm in there? It says very warm.
Maybe it's a little bit hot enough.
Where's the new bottle?
Keep going.
Okay, so we're gonna see if we can find a new bottle of peroxide. And we're going to kind of leery about setting this aside. Hopefully it doesn't.
I'll keep an eye on it. Igor will watch it. But it's slow, don't let go.
All right.
Around, guys.
Yeah.
All right, so we have a new bottle of peroxide. And would you like to pour 4 more ounces of this, ma'am? Or the 1/2 line is. You did such an excellent job last time. Thank you so much. Pardon. Can I see the hot water?
Yes, ma'am.
Okay, you want to pour some dish soap in there? Maybe we try a little bit more dish soap than I put in. Maybe you'll have better luck with it. Might not have put in enough. There we go. All right, and your food coloring, ma'am.
What is that?
Ooh. And can I get a rag, please? I don't want to put yeast in there just quite yet. Thank you. All right. Thank you, ma'am. That's in good? Perfect.
Well, the only good part is with science, if it doesn't work the first time, you try it again and try it again. Work for me. So we're going to do 4 more.
4 more tablespoons of very warm water. It's not boiling or anything like that. We just actually use this to make hot tea. So that's about the temperature that you're going to want it. 3. Oh, and a little extra. So I'll put a little bit less in this one. 4.
Let's see. Mush it up really good.
Try to really mix all that yeast together with the warm water and get it doing its thing. What do we use yeast for most of the time? Anybody know? Does anybody have any parents that bake bread?
Does your mom make bread?
I think that is pretty well stirred. Okay, so this one, we're going to show you the first part and show you how it works. And then we were going to do this so we could make it a Halloween edition. Didn't quite work out, so let's see what happens.
Fingers crossed.
If you guys out there wouldn't mind crossing your fingers for me.
Oh.
Ugh, gross.
It's working.
Can you see it?
Oh, turn it up right.
Oh, it is coming out of it now.
Foaming.
The foam that
Come out. It's kind of oozing.
It looks like it's coming right.
It's kind of warm.
Look at that.
Isn't that cool?
He ate too much candy.
Yes, don't eat too much
Don't
candy
eat
on
too much
Halloween.
candy, that's what'll
And this
happen.
is what's inside.
Ooh.
Can we
Yeah.
point the camera down in there?
Okay, so-
You see that?
Ooh, the inside.
Ooh, look.
Now we're making a mess.
That's why you need the tart.
Yes.
All right. So,
Oh, science. Sometimes it took more than one time. to
It
find.
did, more than one try.
Yeah.
so hydrogen peroxide is made up of oxygen atoms and hydrogen atoms. In this experiment, the yeast worked as a catalyst to separate those atoms. And the bubbles came from the oxygen being separated and going back up into the air. This is an exothermic reaction where heat is given up. I'm not sure if you guys heard Miss April say that the bucket is warm, and if you're doing this, you don't want to get your hands on it because it does get hot. So,
Don't drop dry ice either.
and don't drop dry ice. But we have the tart, so land it on the tart.
We are mad scientists.
So, anybody have any questions?
Any questions about that experiment?
Why does it turn?
What's that? I heard a why something, but I didn't catch the rest of it.
He asked, could you put it in a real pumpkin?
Oh, what would happen if you put it in a real pumpkin?
Oh, I would do the exact same thing. If this just happens to be plastic, because I didn't want to carve a pumpkin just for the
Well,
experiment.
that'd be
So
fun.
I carved a plastic one. But yeah, you can put it in a real pumpkin. You could put it in a bat, in a skull, in anything.
Ooh, a skull would be
Skull would be
cool.
cool.
Yes.
Bubble, everybody.
Do we have any more questions?
Why does it turn into foam?
Why does it turn into foam?
It turns into foam because the oxygen is separating from the oxygen atoms are separating from the hydrogen atoms. When they're combined, it's all liquid and the hydrogen peroxide. This is the oxygen and the hydrogen atoms combined. So when you put the yeast in, it makes them come apart, those atoms. So the oxygen is a gas. So when it separates from the hydrogen atoms, then it mixes with, grabs the bubbles or the dishwashing liquid, and that makes the bubbles. If you YouTube elephant toothpaste, then there are some really great examples of it just shooting up like crazy.
No, he said to Google it.
Any other questions?
Elephant.
All right. Well, thank you guys. All right.
Thank you, everybody. Did
Well,
our,
it's
did our
time
friend
for us to
Tegan
go.
do a good job? Our assistant? We get a round of applause for Tegan. Thank
All right. Well, we hope you have a great Friday. Remember, always do this with a adult supervision. Never attempt anything on your own, or please don't attempt YouTube videos.
That's
No,
right.
don't do it.
YouTube videos are for watching, not for attempting.
Yes.
So thank y'all for joining us. Y'all have a happy Friday and a good weekend.
Thank you. Bye.
Bye.
Happy Halloween.